All right. Okay. Anything else? Okay, I've got a last uh, questions for you, discussion for you. This is interesting and difficult. It happens in one of the exams in the past. So this is good that the recording has begun. Okay, let's try. The question asks us to choose two columns out of A to fit B. And A is equals to 1, 1, 1, 0, 1, 0, 0, 0, 1. This is A. And B is 1, 2, 10. And let's call this column A1, A2, and A3. So the exam question is like this. Which two columns would you choose to find B? If you are actually given all the columns A1, A2, A3 to find B, what do you think B hat is, guys? So the first question is, if all columns of A are chosen, what is B hat? Guys, any? What do you think it is? 1 to 10. What is B hat? Okay, what is B hat? It is A x hat equals to B hat. We want to find B hat such that B minus B hat norm is smallest. So this is the least square solution. A is the matrix, B is the target, AX hat equals to B hat. But we want to find B hat to approximate B. So this is the condition. B hat will be B because A is so what do you think I will say now? So B hat equals to B because so what's the first? Because B is in the column space of A. That's one. The other way, because the other way is because actually it's a square matrix. So A is invertible. A minus 1 exists. Therefore, A minus 1, A x hat equals to A minus 1, B. X equals to A minus 1, B. So I'm going to do this for you. Yeah, and of course, because this is a square matrix and this is 3, so it spans the whole space. So you can write many, many reasons. All these reasons are correct. So I will do it for you. Okay, now you all see my screen. I cannot make this any bigger, unfortunately. And A equals to 1, 0, 0, 1, 1, 0, 1, 0, 1. B equals to 1 to 10. X hat equals to what? I mean, this is the A times X hat equals to 1 to 10. So this notation here, 1 backslash B, is the matrix way of saying find the inverse, find the solution. Okay, the least square solution. So this is easy. So if you get this right, then it's easy. But the second question is difficult. The second question asks, now you cannot choose all the columns. You only can choose 2 of the columns. So therefore, how many permutations can you have, guys? So let us choose 0, 1, 0, 0, 0, 1. We are choosing what? column 2 and column 3, right, guys? I'm choosing column 2 and column 3. And I have A1 here. I also have the same B. Now, in the exams, right, you don't have time to figure this out by brute force. So so you so the trick is this. You guess, right? You guess. You say if I choose these two columns, this guy will approximate 2. This guy will approximate 10. So I'm left with 1. Okay, so I'm only left with 1 that I cannot approximate. Clear, guys? Now, if I choose this and this A1 and A2, it's quite useless because this whole thing is trying to approximate 1 to 10, but this guy is so big. This guy is so small. So, all right, I should choose this guy, the first column, and this guy, because the third column will approximate 10. This guy is left to approximate 2 and 1. Maybe I have a chance. But I'm still confused. I do not know whether I should choose second column and third column, because the second column can approximate 2, the third column can approximate 10 perfectly, and I'm left with 1. So, okay, let's try. I mean, trying to solve this is trivial, right, guys? B hat is, even without any computation, you guys can figure out what B hat is. What is A1? So A1 should be multiplied by what value, guys? I don't even need to compute. It's 210 because 2 will multiply by this guy. So I will get 0 to 10 as my B hat. Therefore, my E is equals to B minus B hat equals to 100. And therefore, the norm of E, I call this E1, is equals to square root of 1. So this is A1. What about A3, guys? B is still 1, 2, 10. Now, B hat is equals to A3 times X3 hat. But what's X3 hat? Then you have to go and compute your equation here, which is what? A3 transpose A3 inverse A3 transpose B. Okay? And you guys go and figure this out. And I will show you in MATLAB as a calculator so that you can do it by yourself. A3 is equals to 1, 0, 1, 0, 1, 1. This is A3. A3 backslash B will give me the solution. And my solution is 1.5, 8.5. Now I can show you the brute force method, which is A3 transpose times A3. This is square. The inverse times A3 transpose times B. Same answer. So whether I do it this way, or in MATLAB, I will do it A3 backslash B because this whole equation, this A3 backslash stand for this whole thing. All right, I got X3 hat. So now I have to do A3 times X3 hat. And what do I get? A3 times A3 backslash B, I get 1.5, 1.5, 10. Therefore, E is equals to 1, 2, 10 minus 1.5, 1.5, 10 is equals to 0.5, 0.50. So now the question is, what is the norm of E? Therefore, the norm of E is equals to 0.5 squared plus 0.5 squared. Answer is 0.707. So therefore, column 1 and 3 from A should be chosen. So let's revise this question again. In this question, we are given 3 columns of A, and we are asked to find X to solve AX equals to B. And we could do this because this is a square matrix. You have 3 independent columns, full rank. We've performed Gaussian elimination. We're very happy. And when we are given the full 3 columns, we can solve X completely. The second question is difficult because out of these 3, we are asked to find 2 of them. Which 2? And this is a machine learning problem in the sense that every machine learning problem will ask you to find a subset of feature vectors, for example, that you can use. So now we are asked to find, and how many permutation? We can do A1, A2, one combination, A1, A3, A2, A3, right? So we only have 3 possible choices. And if you are in the exams, you have no time to do all. You have to think very hard because these numbers will tell you which one to choose. For sure, you are going to choose A3. For sure. Because A3 is 0, 0, 1. This is 1, 2, 10. If you're only given one choice, one column vector, you're going to choose this guy because you're going to project this vector onto this and you get 10 out of the way. Error is left 1, 2. So this is definitely. So only this column vector must be chosen first, and then now you're left with only 2 choices. So the real problem is which are the 2, okay? So of course we choose the last one with the second one first and we try because this looks very, very reasonable. Because I've explained 10, now I'm going to explain 2, right? I'm not interested in 1 because 2 is bigger than 1. I work it out. Brute force, this is brute force. You find that the norm is 1 for error. Here, again brute force. And you find that the norm is 0.707. So this question is a non-trivial question. Okay, guys? So if you look at the past year exam, this question came out and it's not easy. All right. With that, I have another 5 minutes and then I can go into the second part. Could I scroll through the notes above? Yeah, so what I'm going to do for you is this. Okay, since I missed the recordings, right? Oh my God, what have I done? Okay, so since I only recorded half the lectures, I'm going to take these 5 minutes to go through the whole lecture. And I think I can output this as a PDF and then I'll dump it somewhere. But then it'll basically increase your load. All right. Okay. Let's do a whirlwind tour of what I have missed in the last 20 minutes of recording, in the first 20 minutes. This is LA week 9.1, and the problem is to find the projection matrix. We began with the idea that we remember how to project U onto a line, a column vector V. And the answer was this: U transpose V divided by V transpose V. This gives us a scalar. This scalar scales V because we are projecting U onto V. We know that our vector must land in the direction of V. All we are left to find is the scalar. All right, and then it came out that the scalar looks like this. We then says, okay, we are not happy with this point of view. Let us think of another point of view. Another point of view is this. U is our input. There. U hat is our output. couldn't we also think of it as P times U? Oh, yes, we can. So now let us figure out what is P. And we figure out what is P from this equation above here. How? We manipulate. We manipulate by putting the original equation here and start moving things around. Remember, this is a scalar. This is a vector. The scalar, alpha times V, V times alpha, the same thing. So we could move this guy behind. U transpose V, same as V transpose U. So we change the V transpose U and put it in this way. Then we realize that, hey, we can put all these green dots here and solve this first times U, because the whole values don't change. It's commutative or associative. And therefore, now V transpose divided by V transpose V times U is equals to U hat. Therefore, this green box is P, the projection matrix for a single column vector. All right, so we figure this out. Wow, we did it in 2 minutes. Anyway, then we're not happy because we say that, okay, we figure out what is the column, sorry, what is the projection matrix for a single column vector. Now let us play with a column matrix. We want to project B onto the column space of A. So again, we say, isn't there an equation that looks like B hat equals to P times B? Meaning that when I multiply something in front, P times B, I will get my B into B hat. Is there such a matrix? How would the matrix look like? I start with a matrix A that is 4 by 3. I give you a rank 3 because I want to have the chance to have an inverse of A transpose A later on. Not a chance, because if this is rank 3, this guy is 3 column, I definitely will get an inverse. Okay? All right. Anyway, remember, I can never write AX equals to B. I must always write AX hat equals to B hat, because AX can never be B, because A is the columns of, A means the column space of A. Multiplying by X means I must only land on the floor on this space A. I can never reach B. So this equation should be that, something like this, right? Something like this. Right? I'm trying to get as close to B as I want to be. Anyway, so we then derive the normal equation, X approximately equals to B. We derived the normal equation in our previous lecture by simply multiplying left on by A transpose. A transpose A, X hat, A transpose B. Now, this is not a typo, okay, guys? The approximation becomes equality. Means I can definitely solve. There is always a solution. There is always an X hat such that I can find this guy equals to this guy. Then you say, sir, but A transpose A, let's say, does not exist. Then how can I solve? You can, of course, remember, there is always the Gaussian elimination which you can apply, and you have done it in tutorial 1, which solve for this, even if there is infinite solution. What you will get is an infinite solution, okay? You don't get a unique solution, you get a solution exists, infinite. The deep theory is, of course, that A transpose and the column space of A transpose A is the same. Or the other way to say it is A transpose B is now in the column space of A transpose A. Okay, the theory is very deep. We'll not go there. Anyway, because of my suggestion that our rank is okay, then A transpose A inverse exists, and then we can find this least square solution equation. We found X hat, right? And we know that B hat equals to AX hat. So all we did was put this whole thing inside here. And this whole thing inside here have a B sticking out there. Then, voila. This is the projection matrix when we want to project B onto the column space of A. Okay? And then we went through very quickly the properties of the projection matrix, which is two properties. Pn equals to P means I keep on multiplying P by itself. He never changed. P transpose equals P, he's symmetric. And with that, I think I'm done. Right? So we are done with least squares. So let's take a break, a 1 minute break, because I'm now going to start on complex numbers. Is that okay? Must we find the projection matrix or can I just use the formula? Okay, if the question asks you find the projection matrix, then you find the projection matrix, right, guys? So depends on the question. Any other questions, guys? And yeah, I guess I definitely need one of you guys to remind me that I I I don't record. Oh my God, what have I done? Mm. Can we just apply the formula blindly? Of course not. You can't. You can't because if it is not full rank, A transpose A inverse does not even exist. How do we know? I'll show you what I'm reading. Okay. How do we know? We have to know the full decomposition QR with QR with. Okay, I will never answer such questions like this. Okay, I can't answer such question like this because we have already shown you different slides and yeah, you can augment and solve without inverse. I don't know. Okay, but maybe is it okay if I start complex numbers? How's that? Is there any advantage of using QR? Ah, I see. Okay, this is the first course of linear algebra. If you have second course of linear algebra, then you will realize that, you know, if you'll realize that there are many other methods, and in fact, we'll never do any. We'll never find an inverse of a matrix. There are many other ways, and QR is one of the ways. Okay. Aya asks, is complex number part of these squares, or is it a completely new topic? Okay, Aya, let me show you. All right, come on. You will see that the least squares is chapter 8a. And you will realize that we are now in week 9. And actually, I've just finished all this. I didn't want to do applications, right? I could have done 1 more hour of applications, but yeah, I guess you guys can do it by yourself. And I'm starting on week 10 now, complex numbers. And I'm just going to introduce complex numbers. And I'll take 1 hour to introduce complex numbers. Does that answer your question, Aya? Aya? Yes, great. All right. Now, yeah, keep it coming. LA9 in Wool Clap. Yeah, tell me something interesting, please. There are only 13 of you, but there are like 131 of you online. Please. Textbook questions, example questions for practice. Make it more relatable. Cool. The last example is very relatable. Huh? Very relatable. Factorizations. Cool. Past year exam questions. Yeah, I just did past year exam questions for sure. Exam question. More practice. Yeah, but DFT, yeah, coming soon. Confusing. A compound list with examples. All right. Concise. I summarize. Yeah, I did summarize. Yeah, you realize that. But if I summarize it all the time, then it will be very hard for you to follow. Okay, guys? Just very clear. Oh, great. Thank you. Confusing. Oh, appreciate PDF. Yes, okay. I will scan the PDF and I'll put it somewhere. But then, you guys would be telling me that I got more things for you to do. Now, for practices, for practices, I'll suggest you look at MIT, guys. Okay, I'm going to find the link for you. And then, yeah. And, MIT gives you everything. MIT, linear algebra, 18 point, whatever, and questions. And it's very hard. Okay, so you can see problem solving in in their work, and in 18.06, yeah, you can have a list of exam questions. See, everywhere is, I mean, it's, you, I mean, you have more, you have solutions as well. Don't worry. Okay, and there are a lot of things to know. And again, 1806 is a undergrad linear algebra, and I think their questions are much harder than ours. If you can solve theirs, then I'm sure you can solve ours. Okay. Oh, yeah. Strength. Great. Let's see. Solutions are there, guys. Yeah. There are plenty. Okay. See? Looks like ours, right? Cool. Okay. So there are a lot of things going on, more than you ever want to. Okay. So let me just drop it in somewhere for you, and let me put in the chat. Oh my God. I haven't gone through videos for complex yet. Yeah. Yeah, it's okay. You take this as a, what do you call that? As a quick rundown, okay, on complex numbers.